So we've gone to all the effort to make the room soundproof by sealing all the gaps, but we need to breathe, right? So we need to let the air in. But every time you put a hole in the wall, you're letting potential noise into the room. So how do we get around that problem? G'day, it's Rowan from Elfshot Design. In this episode, I'm going to show you how I got around that problem by building custom baffle boxes, which effectively let air come into the room through a series of twists and turns to wash off all the sound, but then get fresh air into the room. And then at the other end, a fan system sucks the air back out. Now this does assume some carpentry skills. I'm not going to go into all the tools required, but I will talk about the materials and the dimensions and some of the design decisions that went into this build. Let's jump in. The system consists of three main parts. First, an intake baffle box that directs air into the room. Second, acoustically insulated ducting where the air gets directed into. And finally, a second baffle box containing a 200mm inline fan. Fresh air enters through the intake box, travels through ducting in the first baffle box, passes into the room, and is extracted by the fan in the second box outside the room. Because the fan's pulling air rather than pushing it, the entire system runs under a slight negative pressure. Before we start cutting timber, here's everything I used for the ventilation system, and it's in the description below as well. The only difference is I made my own external intake vent with steel and aluminium mesh. I had all the materials on hand for this, and I knew I could make it completely bushfire, weather and bug proof using steel construction. You can buy ready-made plastic or metal wall vents for the outside, so that's a whole lot easier. This is made from yellow tongue. It's just screwed together. I'll seal around the inside. And this is actually the bottom side. I've got a foot here that's got the anti-vibration pad on it as well, just to help reduce any vibrations coming in through the box and down into the floor. It stops here because this end is going to go over the bottom plate of the wall. So we'll flip this over now, do a final check for where the hole needs to go through, and then I'll drill a hole in the wall. This cabinet's pretty heavy, so I'm going to chuck a couple of blocks down on the edges just so I can get my fingers under it. The box sits beneath the window and is approximately 1350 wide, 850 high and 400 deep. Part of that depth is recessed into the wall cavity, so it only protrudes about 300mm into the room. I did go ahead before and pre-mark where this is supposed to be, this hole, just by measuring down and across. This is the frame I welded up that'll sit in the wall, and it's designed that the waves of the corrugation are just lined up in the right spot to screw into this frame, this exterior frame. So I'm hoping this is in the right spot. Fingers crossed. We'll push it into place now and do a test fit, and if I'm happy with the fit, we'll drill this hole in the wall, which is going to be this square shape. This is the exterior cowl that lets air come in. It's built over a steel frame, some sheet metal bent over it. Got aluminium brackets underneath here to hold the stainless steel mesh in, and that mesh will prevent any bugs getting in, but it lets enough airflow in as well. It's completely weatherproof. I've used polyurethane sealant so I can paint it for all the gaps, especially up here where it joins the corrugated iron, to ensure that no moisture can get into my baffle box. Internally, the goal is to force the air to change direction before it even reaches the ducting. To create this pathway, I built an internal L-shaped structure from yellow tongue flooring. The ductors are dual layer flexible acoustic type with 200mm internal diameter and an overall diameter closer to 250 to 300 once both layers are included. A steel spring helix runs around the side of the ducting to maintain its shape and prevent it from collapsing. Between the layers is a thin acoustic lining, while the outer foil laminate helps contain and reflect the sound. As sound travels through the duct, it's repeatedly disrupted and absorbed, reducing its energy before it exits. The same L-shaped flow path is mirrored at the other end, where air leaves the baffle box through a simple external vent. So the intake's completely sealed up now. I will just run some sealant around that to seal the cracks. Got the ducting running around here in the S shape, and basically a mirror image of the intake box for the outtake. Goes into there. I've got a bit of acoustic foam just to help sort of break up the airflow a bit. Then it comes out this ducting joiner here. Well, sometimes you have issues and you've got to make compromises. This ring is not deep enough to go in the box there, and also out this way far enough to give this final outer grill enough depth to grab onto. This thing could only go flush with the outer box like that. There's also going to be a layer of plaster here. By the time I add the plaster, this thing here is just not going to have enough depth to reach inside that to hold on. So the compromise is I'll have to run this flush with the outer yellow tongue like that, so this lip can reach the ring, and then that means the plaster board will have to be cut to go around the outside of this instead of this sitting over the plaster. It's not as neat, but it's the best I can do without having to re-engineer this ring or extend this in some way, which I don't really want to do. The result is very little external noise passing into the room, but that's only half the challenge. So this is what I've ended up with. I'll save you guys time, a whole lot of sawdust and cutting and noise. It's an L-shaped box. The fan sits inside the box. This is just to help minimise some of the noise. It won't stop the noise, but hopefully it'll minimise a bit. This will join to the acoustic ducting, the joiner. Air comes in, gets sucked through the fan, changes direction and passes out the bottom. And I'll make a frame for this to sit over next to the studio wall, but isolated from the wall. So while you'll still hear the noise out here in this part of the shed, I'm hoping we won't hear anything in the studio. Now I made this lid removable so I can get to the fan, but I realised I'm going to need to make this two pieces, otherwise I've got no way of getting it open. If this ducting's attached to the fan and the fan's attached to the bottom of the box, how can I open the lid? So I'll chop it here, and this piece will be fixed permanently, and then I'll make sure this section here is easy to open if I need to get to the fan to maintain it or replace it or whatever else. I use regular ducting in this box because I'm not so worried about the noise out here in the shed. It's more about controlling the air pathway. I ended up adding an extension to the fan box, which made it a little bit quieter and allowed me to incorporate one more 90-degree turn before the air exits through a bug-proof mesh grill that's held on with bits of timber. The exhaust box is 1200mm long, with the square sections being 300 by 300, and the vertical section is 1 metre from the very top to the very bottom. The fan itself is mounted on anti-vibration material rather than being hard mounted directly to the box. This might reduce a tiny bit of structure-borne vibration, but in reality, almost all the fan noise is airborne. I did ensure the whole unit sits on anti-vibration pads and doesn't touch the studio wall directly, which I do believe does make some difference. The ducting runs outside for a few metres from the ceiling of the studio, so I've placed bats around it to help deaden the sound. If you're planning to use a speed controller, run the cabling before the walls are closed up. In my case, I had the electrician install wiring to both the fan location and the wall switch position, so a speed controller could be added later. This dial looks like a regular light dimmer, but it's not. Light dimmers are designed for resistive loads like lighting, not electric motors. They control power by chopping up the AC waveform, which works fine for lights, but not so good for HVAC fan motors. If you want speed control, you need to choose a fan with a motor that's designed to be speed controlled. Since my fan has 2 speeds, I've got a hard switch to high, then I'll just use the speed controller. I'll never run it too slow though, particularly in hot weather, because the air passing through the fan cools its own motor. This is what it looks like on the inside. The air passes in up here, goes through the fan. The fan's going to be mounted on these anti-vibration pads, goes through and back out the other side. And it's fairly central. I think I've got enough room here to make the 90-degree bends in the ducting without kinking them. The fan itself sits in a cradle like this, with these little arms that pull it down to secure it. I've got to figure out how to make this thing quiet though. It's quite noisy. Now when I film me using power tools on the channel, I normally dip the volume so you guys don't have to listen to the noise. But I'm going to turn this on without changing the volume just to show you how loud this thing is. So I run the fan on the bench here, and then I'll cut to what it sounds like once it's inside the box. So we'll start with the bench, just a raw fan. The microphone's sort of just over there, so it's kind of like about a metre away from the box. Definitely not quiet, but it's quieter. So how well does it work? I've been using the studio for several weeks now, and overall I'm really happy. The room is extremely well insulated, so it's quite stable against external temperature changes. One thing that surprised me is how little I actually need to run it. Typically I'll switch it on for around 15 minutes every couple of hours, and that's enough to freshen the room up again. That's useful during winter because the fresh air coming in does lower the temperature when the reverse cycle system's heating at the same time. I haven't experienced summer yet, but I can imagine it'll be a similar thing in reverse when I'm cooling the room. Another great outcome is the soundproofing efforts eliminate the sound of the fan just outside the studio. I'll do a quick demonstration by opening and closing the solid studio door so you can hear the difference for yourself. If you watched an earlier episode, you would have seen how this door is sealed on all 4 sides, including the hinges. One interesting lesson I learned was that the internal vent grille in the ceiling actually created a huge amount of gushing wind noise. In the end, I just removed the grille entirely. The whole ducted section is sealed all the way, so I don't have to worry about any bugs getting in. It just looks a bit ugly. Oddly enough though, I'm using the exact same grille on the intake vent at the Baffle box, and it's completely silent, so I've left that one installed. This is what the finished Baffle looks like after I drywalled it completely. Now it's nicely integrated into the room, it sits neatly under the window, and you can't even really see it from anywhere in the room. One slightly annoying thing, I found that the studio door needs to be pulled fully shut. If it's not pulled shut before latching, the negative pressure can create a faint whistle through the door seal. I think I can fix this, probably just a section of door seal that needs adjustment. If I was building this again, I'd still use exactly the same overall design, but I might spend a bit more effort on the fan box. It's still quite noisy in the shed if the fan's running, which could have been reduced if I built a Baffle box similar to the intake Baffle box. Also, it would have been good to test the fans before buying one, because I think if I'd heard how loud this thing was, I would have looked around for other options. For the budget though, I've certainly solved the problem of building a silent ventilation system for the studio. Overall, this has been one of the least visible parts of the build, but one of the most important. A soundproof room is great, but a soundproof room that stays comfortable all day is even better. In the next episode, we'll move on to the acoustic ceiling cloud, where the studio starts looking a lot more like a professionally architected space. Catch you then.